Welcome to this webinar. Before we begin the presentation, I want to provide you with a few housekeeping items. On your screen, you will see a taskbar with icons. Each icon is assigned to a particular element of today's webinar. After the webinar is over, please take our survey to tell us how we've done. Throughout the presentation, you can network with others or submit questions to the speakers in the box next to the slides. Download resources from the folder icon. Today's event is being recorded and archived and will be available within 24 hours. For on-demand questions or comments, send us an email by clicking Email Us. If you experience any technical issues today, please refresh your browser by hitting F5 for a PC or Command R for Macs, or email webinars@bmpmedia.com for one-on-one support. And now I'm excited to turn it over to today's moderator.
Good afternoon and welcome to this webinar, A Changing Tide, the Importance of Video Data Management into Enterprise Environments. This event, brought to you by Security Magazine, is sponsored by Pivot 3. I'm your moderator, Claire Meyer, Managing Editor of Security Magazine. Thanks for joining us. Today's presenter is Brandon Reich, Vice President of Security and IoT at Pivot 3. Brandon leads all product and go-to-market strategy for Pivot 3's global video surveillance portfolio. Brandon came to Pivot 3 in 2014 from Honeywell Security Group, where he led the product marketing and global strategy functions for the commercial and enterprise technology business unit. In 2016, Brandon was named one of the top 12 influencers in the physical security and video surveillance industry by Security World. Don't forget to submit your questions, and later on in the program, Brandon will address as many as possible. Today's event is being recorded and archived on securitymagazine.com. And now I'm excited to turn it over to today's presenter, Brandon Reich.
Okay, thank you, Claire. Thank you, everyone, for joining. Good morning, good afternoon, good evening, depending on where you are. As Claire said, we're going to talk today about the importance of video data management in enterprise environments. Well, what does that mean, do you say? What are we actually going to cover? We're going to take a look at a couple of things. We're going to look at what some of the major trends are in the world of physical security technology, specifically video surveillance, but also the broader world of this new term called the Internet of Things, or IoT, and particularly what the implications are of those technologies on your selection of server and storage infrastructure to underpin all of those various technologies. We're going to look at the increasing interaction between the security department and the IT department, the potential conflict that can arise from that, and more specifically the roles that each of them play and how to mitigate that conflict and ensure that the technology solution that we ultimately select and deploy aligns with both groups' goals. We're going to look at some of the new emerging IT technologies that are out there and how we can apply them back in the world of physical security and video surveillance. We'll take a look at some of the actual business impact of these technologies, and then, time permitting, we'll have a look at some real-world examples and how these solutions are actually being deployed. So let's go ahead and get started. If we look at what's actually happening in the security industry or in the world of security today, I think many of you will certainly be familiar with this and in tune with this. We know that the risk environment, the thing that we are protecting against, haven't necessarily changed much for varying organizations over the years, but certainly the threats against those risks have changed. And so organizations, whether they're businesses, enterprises, governments, institutions, are increasingly turning towards new technologies to help mitigate against those threats. And all of this new technology is generating just absolutely massive amounts of new data. And of course, because of this, this data is more important to us than ever before. Therefore, we have the end users have really zero tolerance for things like system downtime and data loss that just a few years ago may have been a relatively commonly accepted situation to happen in our security technologies. Well, all of this has major implications now on how you select your underlying server and storage infrastructure that all these solutions run on top of. We need to look for infrastructure that can deliver performance, resiliency, and scalability to meet the demands of these modern technologies. And we'll talk a little bit later about what performance, resiliency, and scalability means and why that's important to each one of you. We all know there's lots of major trends happening in the world of video surveillance and physical security technology. And a lot of these things that we call trends may sound like buzzwords to you, but when properly planned and deployed, a lot of these technologies can deliver real value to an end user organization. Now, these are just a few that you've probably heard of a lot in the past year or two. Things like security and cloud and artificial intelligence. But all of them, what I want you to understand is that all of them have a significant impact on a system infrastructure selection. Now, one of the biggest buzzwords out there, or the biggest trends really in the industry, is this one that's emerging now called the Internet of Things, or IoT. And IoT is really, what it really means to me and to others that have been in and around this for a long time, what it really means is the ability to transform data that's being generated by dozens or thousands or even millions of sensors of some sort into some kind of actionable intelligence. Now, if we've been around the video surveillance world for a while, we say that video has been at the forefront of this IoT revolution for years. And in fact, many people would say that a video surveillance camera was the original IoT device or IoT sensor, even though we didn't necessarily call it IoT way back then. But recent advancements in video technology, in new use cases for video, and declining cost of video are really driving the demand to previously unforeseen levels. And as a result, video increasingly now is moving away from the traditional store it in a closet on a floor of a building somewhere, and increasingly now into the data center under the auspices of the IT department. And that brings with it new expectations for things like server virtualization, for much simpler and standardized management, for resiliency, for cloud security, for cloud solutions, and for, of course, data security solutions. So we have to think a little bit differently about our infrastructure going forward. Now, before I get too detailed about the technology, let's look at some of the projections right now. You see in the chart on the left-hand side of the screen, it's forecasted that almost 90 million new cameras, new IP video surveillance cameras, will be delivered this year in 2018, and next year will go for the first time over 100 million. Now, what doesn't necessarily show up in this chart on the left is the mix of higher and higher resolution cameras that are being deployed. You know, just a few years ago, a 720p or a 1080p camera would be considered really highly advanced technology. Nowadays, it's really table stakes. That's really a starting point. We're increasingly seeing 3, 5, even 10 megapixel cameras, multi-imager cameras, 180 and 360 degree cameras, and being increasingly used. And the importance of that is that each one of those higher resolution or new types of cameras are generating more and more data. And you see this now coming through in that chart on the right-hand side of the screen. A couple years ago, or excuse me, last year, an IT analyst firm called Wikibon put out a study, and what it showed was that video surveillance is today, and is forecast to continue to be, the largest big data application in the world. This study looked at how much new data is being generated by all of these various technology applications globally. And they found that video surveillance is going to generate about 24 zettabytes of new data this year in 2018. Now, to put that into perspective, you can see on the chart there the second closest application, one called data processing, which is really sort of a catch-all for all the things that happen inside of a data center, is about half that amount, roughly half that amount. Now, what's more is the rate of new data generation from video surveillance is growing at about 42% per year. So this deluge of new data obviously has significant implications on your underlying server, your data storage, and your networking infrastructure. And I will assure you it's absolutely going to grab the attention of your IT departments or the IT departments of your clients and your customers. So as I said before, IT is increasingly involved in physical security technologies, at least in the infrastructure, decision making, selection, and ongoing management and administration. And while IT shares some of the goals of our security departments, many of the expectations between IT and security can be different, and sometimes that can lead to a little bit of conflict. So let's look at what is it that's important to each one of these departments, and why does this matter to us? The security department is obviously concerned, when selecting technology, is obviously concerned about preventing downtime and data loss, ensuring that their systems are always online, always operating, and they always have access to their data. Controlling costs, of course. But they're also interested in things like open platforms, in reliability of their systems, in simplified management. They don't want real significantly complex or sophisticated technologies that require a deep background in IT to interface with. And of course, physical security. Now, ultimately, what they're driving towards in the organization is managing risk. Their job is to help their organization manage risk, both physical, logical, and in some cases even business risk. On the other side, we have our IT departments. You see that some of their goals overlap with security. Of course, they want to prevent downtime or data loss in their systems. In fact, things like downtime and data loss are maybe some of the worst things you can ever bring up to an IT person. These are the things that keep them awake at night. Downtime and data loss are the things that cause them to lose their jobs, right? Of course, they're also concerned about controlling costs, but this is where some of these needs tend to diverge a little bit. Now they look at things like, instead of open platforms, they look at how familiar is the vendor that we're going to be working with. You know, how familiar am I? Do I know their technology? Do I use them in other places in my data center? How can I consolidate multiple different applications or multiple different workloads together onto common infrastructure so I can reduce footprint in my data center, so I can reduce the amount of time and effort and energy it takes me to administer these systems? Can I integrate the management or the administration of all these different systems together so I don't have hundreds or thousands of disparate systems sitting inside of my data center that all require separate management and administration and maybe tools to interface with? And of course, how do I control, how do I ensure security of the data itself that I house in my data center? So an IT person will say, while we're there to manage risk and we're there to be partners to our security counterparts, what we are ultimately most concerned about when it comes to selecting technology is how do I manage the complexity of that? How do I keep that down? So these goals, while somewhat aligned, can often diverge, and this can lead to conflict between security and IT, and that conflict is a recipe for disaster when it comes to deploying your solution. So how do we resolve this? And one of the things I'll say is that you as a security person, likely as a security person or as a security partner, need to really play the role of educator. Now, most people on this call, I think, likely come from the security world, from a security background. So let's talk a little bit about how we can educate our IT counterparts in order to ensure proper collaboration between our groups and achieve all of our goals together. The first thing that I talk about is that IT needs to understand that video surveillance is different. In fact, it's very different from virtually all of the other applications that they are primarily familiar with and that they host inside of their data center on a daily basis. And because of that, traditional or conventional infrastructure solutions can really be suboptimal for a video surveillance, particularly an enterprise video surveillance type of deployment. However, there are new technologies, new IT technologies that are emerging in the data center world that can be leveraged in a way that help us both achieve our goals of reducing risk and reducing cost and complexity. And ultimately, what that means to an IT person is we can make your lives much easier and make you much more effective in your roles. So why is video different and why should IT care about that? I told you before we wanted to talk about performance, resilience, and scalability. And right now I'm going to talk about why those three things are so important. First of all, performance. When I say performance, what I mean is a infrastructure or a server and storage system's ability to take in or to ingest data without any kind of loss. Okay, so video surveillance is a very write-intensive application, and spikes in that data are very common. Now that's very different to most other IT applications that are out there. General rule of thumb, most IT applications now, 80% of the time they are reading data from a disk, and roughly 20% of the time they're writing data to a disk. Video surveillance is the exact opposite of that. It's more like 95 or 99% of the time data is being written to a disk, and a small fraction of the time is data being read back and retrieved from that. Now this combination of write-intensive workload and highly variable data ingest or data spikes can quickly overwhelm a traditional storage system's ability to ingest that data without loss. Most storage solutions are built and optimized for that 80% read, 20% write kind of ratio that I just talked about, and not for something like video surveillance. That leads to data loss, or in the video world we call that frame loss, which has some really bad implications. Ultimately that reduces the effectiveness of our video surveillance systems by degrading the quality of the recorded image, or if we lose the wrong frames, can actually lead to the loss of entire segments of video. So the performance of our system to ingest and take in all of that video is critical for us. Secondly is resiliency. When I say resiliency, what I mean is protecting our systems and our data against major hardware failures, against downtime and data loss that can result from major hardware failures. Now believe it or not, the hardware that's used in video surveillance is, by some accounts, I think it was Google that actually put out a study on this that said the hardware used in video surveillance is about 3 times more likely to fail when that same hardware is used for other applications. And a lot of that goes back to what I said before about video being a very write-intensive and a highly variable workload. This puts a significant amount of pressure on the hardware itself and puts it under a lot of stress. So most IT departments will say, okay, that's fine, but we have plenty of conventional tools and technologies and methods of protecting systems against downtime and data loss. Things like data replication, snapshots, backup, RAID, the cloud increasingly is becoming one of these. And my response to that is, well, that's fine. However, you need to understand that many of these technologies don't work for video surveillance. You can't do snapshots on the video surveillance systems. It's very difficult to effectively back up video data and then restore it and still be able to retrieve that video because of losing synchronization with VMS databases. So many of these solutions just don't work, or in the case of solutions like data replication or the cloud, can really be prohibitively expensive to deploy in a storage-intensive environment like video surveillance. So we have to look at what are other ways to protect our systems against downtime and data loss. And then the last part is scalability. You know, one of the least kept secrets in the world of video surveillance is that video systems never get smaller, and in most cases, over time, they almost always get larger. And there's different reasons for that. It could be adding new cameras, it could be upgrading to new technology, it could be the availability of additional budget, lots of different reasons. But there's a common misperception out there that as a video system gets larger over time, we simply have to scale our storage capacity in order to keep up. And while that's true, you do have to scale storage, you also have to scale your compute and your bandwidth capacity typically together in a linear fashion with storage capacity. And you need to do so in a way that's non-disruptive to your existing systems. So we need to think about this. Performance, resiliency, scalability, these are all very important topics to understand as we plan our video surveillance infrastructure solutions. So let's take a quick look at, at some of the options that you have available to you today. The first one that I think most people will be the most familiar with is probably the most common type of architecture in our industry today, and that's a network video recorder or an NVR. In the IT world, we refer to this as direct attached storage. But basically, this is a server, a standard server, combined together with video management software and deployed as an appliance. Now this architecture, for the most part, is fairly antiquated. It really doesn't work well for larger enterprise systems. My guess is that if you're on this call today, you're probably not considering this type of architecture, but if you are, I want you to consider it very closely. NVRs, quite frankly, were designed to look, act, and feel like an older analog VCR and a DVR. But as cameras transitioned from the older analog technology to the newer digital IP technology, the underlying infrastructure needs completely changed as well. And as a result of this, while NVRs today can work well for smaller systems, and when I say smaller systems, think about less than 70, maybe 100 cameras at the most. As those systems get larger, this NVR architecture can pose some major challenges. Major challenges around meeting required retention and performance requirements, introducing single points of failure, poor levels of data protection, and quite frankly, as these systems get larger and larger, and NVR itself is not scalable. You can't make an NVR larger. You can simply add more NVRs to your system. That gets very difficult, unwieldy, and expensive to manage at scale. On the other end of the spectrum, the IT world would say, you know, we abandoned that physical dedicated server architecture years ago in our data centers because of those issues and those challenges that I mentioned. And they moved to more of this enterprise architecture where you have a group of servers, application servers, either physical or virtual, and typically together in a data center accessing a shared storage medium like a SAN or a NAS kind of solution. And this can solve a lot of the challenges that MDRs pose for larger systems. But the biggest problems you'll face with this kind of architecture is that they weren't built for video surveillance. They're built for that 80% read, 20% write ratio that I told you about before, and as a result, they perform very, very poorly for a video surveillance application, and that leads to those problems with image quality degradation and video loss that I told you about before. What's more is that these kind of solutions tend to be very expensive, built on single-purpose proprietary hardware, and require some fairly highly skilled, in many cases highly paid people to manage on a day-in and day-out basis. So before I tell you how you can go and solve all these problems, I want to shift gears for just a second and talk about one of the major trends that's happening in the world of IT. Now, like most functions, our IT organizations for years have been looking for ways to reduce cost and complexity, and they've taken a very hard look at their data centers. And what they found is that actually these data centers are really major, massive cost centers. And so some of the major innovators out there in the IT world, like the Amazon, the Facebook, the Google, et cetera, have come up with ways to eliminate a lot of the proprietary hardware in their data center and vastly reduce the cost and complexity associated with it by building out their own infrastructure based on software running on low-cost, standard, off-the-shelf commodity hardware. Now that's great for a company like Amazon or Facebook or Google, but the reality is that most organizations don't have the ability to build this kind of data center solution on their own. So they've looked around and they said they need a solution that they can invest in that has the same kind of features and benefits of what Amazon and Facebook and Google have done, and that's led to a new category of data center technology called Hyperconverged infrastructure. Now, or HCI. And now it's not critical to deeply understand what HCI is and how it works. I'm going to talk to you in a few minutes about specifically what this looks like and how you can use it in your physical security deployments. What's important to note is the basic concept of HCI, which is taking the traditional data center infrastructure that you see on the left-hand side of the screen, taking all of the servers, the virtualization, the data storage, the networking, all those different components, and effectively mashing them together, replicating their functionality through software, and running it on standard off-the-shelf server hardware, low-cost server hardware. This is important for organizations to helping them reduce cost and complexity within their data centers. Now, HCI has been emerging for the past 5 to 7 years or so. And the early versions of HCI were really built and optimized for single purpose use or single application use. The latest iterations over the past 2 or 3 years of hyperconverged infrastructure have been optimized now to run multiple workloads or multiple applications together, and enabling them to take over larger and larger pieces of the data center. This is important because this trend is highly disruptive in the IT data center infrastructure technology world, and is starting to make its way now into other aspects, other applications, other related industries. And that's where I want to bring you back to what we do here at Pivot 3. We have taken the concept of hyperconverged infrastructure that I just mentioned and brought it back to, or adopted it specifically for video surveillance and related physical security and IoT applications. Helping you and helping your customers solve the challenges in video surveillance that we've been talking about for the past 30 minutes. So at a high level, I won't go in deeply into what the technology is, but I want to explain very briefly how it works and what some of the benefits are. If you look at the diagram on the left-hand side of your screen right now, hyperconverged infrastructure effectively takes the best of both worlds, from the NVRs to the enterprise storage that I mentioned before. We start with standard off-the-shelf server hardware, in many cases the exact same hardware that are used in many NVRs. We deploy that hardware in groups or in clusters. You see 3 of them on the screen here. We can go all the way up to 12 of them inside of a single cluster. And then there's a couple of pieces of software that are installed on every one of those servers to turn a group of those servers into really an enterprise class data center optimized for a specific application. The first, represented by those gray boxes on the left, is server virtualization software. We can virtualize a number of different physical servers that may be used to run different systems, like VMS servers, or access control servers, or analytics servers, or building management, or PSIM, or whatever those servers happen to be. We can virtualize them and typically consolidate them down onto a smaller amount of hardware. And then secondly, we have our software, which is called Acuity, that runs on each one of those servers and does a couple of things for us. And this is really where the magic happens. Acuity does a couple of things. Number one, first and foremost, it takes all of the storage resources inside of each one of these servers, the hard drives, solid state drives, even the bandwidth on the back end, and it aggregates them together into one common pool of storage that we call a virtual SAN. Now this virtual SAN, the entirety of this virtual SAN becomes fully accessible by every single application, every single virtual machine, those gray boxes you see on the left-hand side, and effectively then every single camera in the entire system, regardless of which physical machine that camera is associated with. Secondly, Acuity acts as the storage controller inside of this platform. Now what that means is the software actually manages how data moves from the application, from that gray box, down to the physical hardware layer. And it's because of that that we're able to optimize our solution specifically for that write-intensive, highly variable application like video surveillance. So some of the benefits you see on the right-hand side, I'm not going to go deeply into the technology today, but I want to point out a couple of things here. One is it gives you the ability to deliver the highest level of resiliency to eliminate downtime and data loss. A couple of ways we do that is by having integrated server failover or virtual machine failover, so that if a server fails, all of the applications on that server, regardless of what type of application it is, will automatically fail over, restart itself somewhere else in the cluster, so you have no downtime associated with your systems. Secondly, all of the data, the previously recorded video or the other data associated with that failed server, remains not only protected, but instantly accessible at all times. So in the worst case scenario on a video server, if the box just completely fails, just to pull the power cord out and just goes offline, all of your applications will restart, meaning you're back online, you have access to live video, you're continuing to record, and all of your previously recorded video associated with that failed box remains protected and accessible. Secondly, is because we're optimized for video, we will achieve the highest levels of video ingest performance and eliminate frame drops, and we will sustain that high level of performance, again, even during major hardware failures. In other types of storage solutions out there, when hardware fails, You go into what's called a degraded mode, and suddenly your entire system slows down. We will prevent that from happening. We are highly scalable. We enable you to start small, as few as 3 of these nodes, and then scale over time as your needs and your budgets change to effectively infinite size. By adding a single node, a single box into a cluster, you scale your storage, your compute, and your bandwidth to the entire cluster in a way that's very simple and is non-disruptive to your existing application. So as your needs change over time, you can easily scale this system out. Next on the list is workload consolidation. We give you the ability, because we have virtualization integrated into our solution, we give you the ability to consolidate multiple different systems that typically run on multiple different servers together with typically less amount of hardware, and vastly improve the performance and manage the performance of each one of those applications individually. This is very unique to what we do. The ability to consolidate multiple applications and guarantee performance to each one is very unique in this industry. And now we can deliver all of this enterprise class capability, this enterprise class technology, without the cost and complexity typically associated with enterprise class infrastructure. Okay, we do that by automating many of the day-to-day maintenance activities and greatly simplifying the management of this system on a daily basis. So that's an overview of what the solution looks like. Most of you now are probably saying, okay, that sounds great, but what does this mean to me? What does this mean to me in my business? What does this mean to me in my organization? If I'm a government, you know, what's the so what here? Why do I actually care about? Why do I care about resiliency, performance, consolidation, simplified management? Well, it comes down to this. Better resiliency by preventing downtime and data loss that result from hardware failures means you reduce the overall risk to your organization that may be introduced by the technology itself. Higher performance means, by eliminating frame drops and ensuring that we maintain that high level of performance, means you maximize the effectiveness of your security systems and ensure that you're always getting the performance out of them that you need, always ensuring that they're operating at their optimal levels at all times, even during hardware failures. Of course, consolidating workloads, consolidating applications together helps you reduce equipment and all the associated things that go with that, which of course reduces your costs. And by simplifying the management and adapting this specifically to the way that IT needs and expects to manage these systems, just the same way they do all the other systems in their data center, it helps you lower the ongoing cost of owning and operating these systems over time. Now, a common question I get before I show you some real-world examples is, who are you integrated with? Who have you worked with before? You know, this sounds like great technology, but are you an open platform? And my answer to that is yes. We are a completely open platform. We have tested, certified, and deployed with virtually all of the major video management software and related applications in the industry. If you happen to find one that we haven't tested or deployed with in the past, let us know. If there's an opportunity there, we will bring it into our validation labs and get it tested and validated and ensure that everything works. But we are a completely open platform. We have yet to find one that won't run on our infrastructure. Okay, I want to take a look at a couple of real-world examples and how these kinds of technologies can be deployed and how they have been actually used. The first one is the University of Central Florida. Now, this is an interesting scenario because UCF had a situation a couple of years ago where there was an active shooter on campus. During that incident, while that incident was occurring, the public safety or the campus police department technically had access, or thought they had access, to their video surveillance systems around campus, and they wanted to use that video to pursue this suspect during the incident. However, while this was occurring, it took the public safety department 4 hours to get access to that video. Anyone that's been in and around the security world for a while knows that 4 hours is about 3 hours and 59 minutes too long. Okay, so luckily in this scenario, the shooter's gun actually jammed and he didn't cause any harm to anyone other than himself. However, after this incident was contained, the public safety department partnered up with their counterparts in IT and a newly formed emergency management department to really take stock of what happened here. And what they found was interesting. They found is around campus, UCF, by the way, is the second largest university in the country by enrollment. They found that they had 58 separate standalone video surveillance systems around their campus. In addition to that, they had a whole bunch of additional integrated systems like access control and visitor management and all kinds of other systems in there as well. So they partnered with their IT department and created a centralized infrastructure that could host all of these different systems together in one location and create a much safer environment for their students. So the bottom line is they made a safer campus. They gave their first responders, their public safety, their emergency management department the ability to review video and other security systems in real time, give them the ability to use that data or that information during actual response. At the same time, by doing all of that, they met their IT department's needs by reducing the complexity of managing all those 58 different separate individual systems, which I think we all know when you have 58 separate systems you have to manage, the reality is that none of them probably are getting managed appropriately. So they met the needs of both their security department, the security needs on their campus, as well as their IT needs, and ultimately were able to actually reduce the overall cost of their operations as well. Another example is FedEx. In fact, this is FedEx Ground. FedEx is a very different situation. This is a highly distributed environment. They have over 1,000 warehouse and distribution facilities. Each one of them have a relatively small number of cameras compared to something like UCF that has thousands of cameras. We're talking about 30 to 50 cameras per site here, each one of them. The challenge that FedEx has is that they had no on-site IT resources available to manage their systems on a day-in, day-out basis. So they needed systems that could be easily deployed and centrally managed by their IT department without having to have a physical presence on site. So they began deploying Pivot 3 Hyperconverged a number of years ago to run their video surveillance systems. And then over time, what they found was they could leverage their investment in that infrastructure to run other systems in their warehouses as well. Things like pick and pack systems, like their HVAC systems are being run there. I think they've even got a couple of email servers and things like that, all being run on this hyper-converged solution that was originally deployed for video surveillance, but that can all be centrally managed in one location. So what was important to FedEx was the rapid deployment of these new facilities, centralized management, but ultimately what it evolved into was the ability to consolidate multiple different workloads together onto one common infrastructure, almost like a warehouse in a box from an IT perspective. And the last one that I'll talk about here before I wrap up is Iron Mountain. Iron Mountain, many of you I think are probably familiar with the name. This is a company that has historically worked in the data records retention business. They would take all your records, haul them away somewhere, and store them inside of a mountain for long-term archiving and safekeeping. They also had things like shredding services and whatnot that went along with that. Well, about 7 or 8 years ago, Iron Mountain decided to extend those services away from just physical records and into digital records as well. And they created a service that they called the Iron Cloud. Iron Cloud is what it sounds like. It's a cloud-hosted data center inside of a mountain that is primarily used by organizations to back up and retain their digital information, their digital data. Well, just about a year ago, Iron Mountain decided to create a portion of their system of their Iron Cloud system for a video surveillance application. And they created something called the Iron Cloud for Video. The idea being that organizations, whether it be a company or a transportation system or a government or whatever it happens to be, needed a place to securely archive and store certain aspects of their video for extended periods of time in a highly secure, in a highly reliable, and in a cost-effective manner, somewhere other than in spinning disks on their, on their premises or on a tape or something like that, actually in their facility. So Iron Mountain did that. They launched this Iron Cloud for Video. It offers, as a service, it offers long-term video archive, video retention. They have something called a digital evidence locker that allows you to consolidate things like evidentiary video clips along with investigation reports, along with evidence, along with all kinds of other things together in one place, buried about 700 feet below the ground inside of these massive data centers that they have underneath the mountains that are super highly secure and super highly resilient. Well, when Iron Mountain was building that, obviously they needed enterprise-class infrastructure that could meet these huge storage requirements that they had, and that could do so in a way that was effective for video surveillance. So they selected Pivot 3 to help them build this, and what they ultimately had to deliver, what was most important to them, I can get ahead here, there we go. What was most important to Iron Mountain was to enable them to launch this service with a infrastructure that was highly resilient, that was highly protected against any kind of hardware failures, that ensured high levels of availability and extremely high levels of data protection, because now they're talking about protecting their customers' data, not just their own data, and would do so in a way that was really price competitive versus any kind of alternative enterprise offerings that were out there. So 3 different use cases there. There are many of other types of use cases that are all representative of these kind of things. Ultimately, what this comes down to is organizations that need to ensure the reliability of their critical video surveillance and physical security systems can increasingly leverage new and emerging IT technology to help them do so. So I want to say thank you. I think we're going to open it up for questions here, but I do want to say thank you to everyone for listening today, for taking the time, and I'm happy to answer any questions that may have come through as I've been talking today.
All right. Well, thanks, Brandon, for a great presentation. So now we're going to address some of the questions that have been submitted throughout the program. Feel free to keep sending in questions during this Q&A, and any that we don't get to, Brandon can follow up after the event. So first off, can you speak to Pivot 3's work with law enforcement agencies? How are police departments implementing this technology?
Yeah, sure. You know, it's interesting. Law enforcement is a fairly unique and really an emerging opportunity and use case for video surveillance. You know, we're seeing lots of cameras being deployed for law enforcement, especially things like body-worn cameras, in-car cameras, all of the related, you know, smart and safe city cameras, courthouse cameras, you know, all of these kind of things that come together. What's interesting about this is because they are public agency, they often have pretty strict requirements to retain video for what is increasingly an extended period of time, and that retention is typically kind of governed by specific jurisdictions, and sometimes it relates to all video, sometimes it's only evidentiary video. It can kind of go back and forth. But what's critical to them is once they have it, once they store it, especially if it's evidentiary, they have to keep it. And if they don't meet their regulatory requirement for retention, if they don't meet their, you know, their stated policies around retention, they can subject themselves not only to liability and penalties, but the thing that law enforcement agencies are the most concerned about is their public image and how they interact with the public. And if they don't have that video there when it's requested through Freedom of Information Act or whatnot, it can be really damaging to them. So they look at solutions like what I've been talking about today as ways to ensure, to absolutely 100% ensure that even when hardware fails, which it is going to do at some point, that data remains protected. There's been examples of a couple, I don't want to name them on here, but they have been pretty public, a couple of law enforcement agencies that systems have failed and they have lost petabytes, literally petabytes worth of data because there was no really viable way to back that data up and protect it. And when hardware failures occur, that data gets corrupted and it's just gone. And that just has really significant consequences to them. So law enforcement is a very interesting application and use case for technology like this.
Now, what other types of applications can you consolidate by virtualizing a video system?
Well, what we have seen most is certainly application consolidation is not limited to physical security applications, but what we have seen is that in many cases our solutions are initially purchased and deployed for video surveillance because that's the one that's the hardest to kind of manage and maintain from a storage and compute standpoint. But then it's very simple to consolidate lighter weight and related or integrated applications. Like the ones we've seen the most are access control, visitor management, PSIM, all of these systems that tend to integrate with and interact with video surveillance are pretty easy to consolidate. And the one that's really come up in the last, let's say, year and a half to 2 years has been video analytics and artificial intelligence. And that's really been enabled by some major advancements in analytics around things like machine learning, around GPU acceleration, things like that, that we've been able to incorporate into our platforms to enable things like analytics to be consolidated. And this is important because most of these kinds of systems, like access control, like analytics, like visitor management, PSIM, a lot of them do not have any kind of failover capability. They don't have any kind of data protection capability. They don't have any kind of performance management. They often require dedicated, standalone, expensive server hardware. So by being able to consolidate them all together, not only do we reduce costs, but we bring a level of resiliency to them that they can't achieve otherwise.
Now, can the Pivot 3 solution be managed by an IT department using their normal system management tools?
Yes, that's a good question. That's, in fact, one of the things that we designed into the solution because we rely heavily on standard server virtualization technology, we heard from our IT customers that they need to be able to manage those virtual machines and the storage platforms through tools that they use already. So the virtualization platform that's the most common out there is from VMware. That's what we use. We use a tool called ESXi as the virtualization component. And what we have done is developed a plug-in to a VMware tool that's called vCenter. And vCenter is what's typically used to manage all of these virtual machines. We plug directly into that, so an IT department can actually manage not only the virtual machines, but they can actually manage the storage in our system directly through their vCenter application, which is what most IT departments use today for system management. So the answer to that question is yes. That's a good question.
Now, a lot of VMS companies recommend that servers not be virtualized. How do you overcome these limitations?
Yeah, that's true. And so that's a good question, and I want to address a couple of things around that. The reason that VMSs typically recommend against virtualization is that virtualization in any other platform, there's a process that happens. When data comes in, it actually gets handed off from the VMS to another application, to the virtualization software itself, before it gets written to disk. And that process of handing off can actually introduce a significant slowdown in write performance. Now, for most applications, that's not a big deal, but for video surveillance, write performance is most important. So typically, video management software recommends against virtualization because of that. What we have done is we've eliminated that write performance slowdown by what it's called bypassing the hypervisor. The hypervisor is the virtualization software. And what we do is instead of handing data off to the hypervisor and allowing it to manage data down to the disk, we actually allow the data to go directly from the application straight down to disk. So what that means is we allow you to virtualize your video systems and all your other systems together without incurring that write performance slowdown that you would normally see in virtualization. So that's how we get around it, and that's another patented part of our technology, something that you won't find in other solutions out there.
All right, well, we have time for just one more question. Do you think video systems will move to the cloud?
That's the billion-dollar question, right? You know, we've been talking about cloud in the video industry for years now. Like most other technologies, the security world has been a little bit slower to adopt the cloud than maybe some other industries have. But I think there are real reasons for that. You know, moving video to the cloud, video is extremely bandwidth intensive, requires a tremendous amount of bandwidth, requires a tremendous amount of storage. These things are very expensive and can also introduce some technical challenges when putting large-scale video into the cloud. Now, I do believe that cloud is going to play a role in our industry going forward. I think you're going to find it to be very prevalent at the lower end. I don't mean to call it a low end of the market, but for smaller systems, you know, less than 20 cameras or so, I think you're going to start to see them move to the cloud. And then what I think you're going to see is different components of a video system moving to the cloud. It could be that the VMS moves to the cloud while the data remains stored on premises. Or maybe your video analytics moves to the cloud while everything else remains on-prem. So I think you're going to start to see more of this hybrid cloud architecture start to emerge in our space that enables parts of the systems to move to the cloud. But I think it's pretty unrealistic to say that in an enterprise class video deployment with hundreds or thousands of cameras, that all of that's going to move to the cloud anytime in the next 5 years. I just think it's going to be too cost prohibitive initially.
All right. Well, that's all the time we have for questions today, so please join me in thanking Brandon Reich for his presentation, as well as our sponsor, Pivot 3. If you have any additional questions or comments, please don't hesitate to click the Email Us button on the console. As you exit today's webinar, please take a couple moments to complete our survey. We strongly welcome your detailed comments. Please visit securitymagazine.com for the archive of this presentation, as well as information about our upcoming events. We appreciate your time, and I hope you found this webinar to be a valuable experience. Thank you.